So I want to build off of the example that we looked at yesterday. We cut our boundary at 10. And I saw people draw rectangles. Is that correct? So here was a rectangle that somebody drew, which is a good idea. They drew a rectangle like that. I saw some people draw, say, a rectangle like that, and a rectangle like that, and a rectangle like this, and then maybe another one over here. Is that going to underestimate or overestimate the area? That's going to underestimate it. Everybody agree? Suppose, and if you look here, all right, and I know it's, when I say you're estimating, a lot of people are like, well, this isn't real math. This isn't what we're actually supposed to do. Yes, you're going to be asked to do these things on your test. And here's one part you want to consider. Do you see this rectangle right here, the one between 2 and 4? See how I drew the height from 2 up to the function? So I focused on the left-hand side of the interval. You see that? Now I'm going to draw it to the right-hand side of the interval. So watch the blue ones I draw. Look at this rectangle. Will that underestimate or overestimate the area? That will overestimate the area, won't it? And so if I draw it to the height of the right side, now all of a sudden in this situation, I'm getting an overestimation. So it looks like the black is an underestimation, and it looks like the blue is an overestimation. Agreed? What would happen if we averaged them? That would become closer, wouldn't it? And you're like, well, what would that look geometrically? It's pretty simple. Watch how this works. If you were to average them, then wouldn't you simply get the trapezoid? So if somebody would have gone ahead and done the average of those two, you would have come up with the area that would be shown by the green. And although that area is not exact, that is, as you can see, a slight underestimation, especially in the last one. The green's a really good representation, isn't there? If we wanted it to be even better, then instead of drawing 5 rectangles, we could move to 10 or to 20 or to an infinite number. Eventually, you will add up the area of an infinite number of rectangles. It is one of the most amazing and beautiful things you will ever do mathematically. But we are not ready for it. What we are ready for is to start with 2. Flip it over. Calculus has big questions. The first big question is this. How do you find the slope of a line tangent to a curve at a given point? Have we answered that question? We have. The derivative is the solution. How do we answer this question? What is the area under the curve from A to B? That's a really good question. I mean, that's how solutions to big problems start. Somebody comes up with a really good question. And the reason why it's a really good question is that's not a circle. That's not a trapezoid. That's not a triangle. Those are easy things to calculate the area. That is not a shape that we have a formula for. So what do? We start by approximating. We're going to find the area bounded between the curve x squared, the x-axis, and the line x equals 4 by constructing 2, 4, and 8 rectangles. So the first thing we do is we draw the function, x squared. It says I'm going to find it bounded between x squared, the x-axis, so the x-axis would be this lower portion here, and then the line x equals 4. What kind of a line is x equals 4? Vertical line. So we're going to put 4 right there, vertical line, boom. Everybody got it? Can you see the area that we are trying to determine? Good. So I still need to make copies of your homework, so I would like to do the first two together and then have you do the third one on your own within groups, and then we can check. That way I can quick go start your copies. That's the plan. Everybody ready? Okay. Now, on the previous page, I talked about left hand and right hand. Today, everything will be right hand. Everything will be right hand today. When you get back on Monday and Tuesday, we'll talk about left hand, trapezoidal sum, midpoint sum, the whole rest of the deal. Today is right-handed. So I want to divide it up into so that there are two rectangles. Two rectangles. So if I'm going to divide this region up into two equal rectangles, what's going to be the width of each rectangle? 2. So I'm going to put a mark at 2. And notice I have this first interval, 0 to 2, and I have the second interval, 2 to 4. So I'm going to draw right-hand rectangles. And what right-hand rectangles mean is I go to the right side of the interval, and from there I draw to the function and over. So is that an underestimation or overestimation? Overestimation. Is everybody okay with that? Now I go to the 2, 4 spot. I go to 4, I draw under or overestimation? Over. You can see it is a very poor estimation, but we are going to move it to a close estimation in not too long. So we want to simply find the area of those rectangles. How do I determine the width of the rectangle? Yeah, it's just 2, right? So it's going to be 2 times something plus 2 times something. Please focus. How is it that I determine the height of the function? Plug in 2 to the function. So 2 squared is, so that's the height right there. It's 4 units high. What is the height of the function here? It is 16. So 2 times 4 is 8, plus 32 is 40. So 40 is a gross overestimation. Agreed? Okay, let's simplify our work to some degree. As long as we are dividing them up into equally spaced rectangles, notice how each time it's the width times the height and the width times the height, right? So you could have factored that out to be 2 times 4 plus 16. Agreed? So now it's the width times the sum of the heights. See that? So our formula will simply be the width times the sum of the heights. Now I apologize because you can't really erase very well and I can, but I'm going to have to erase this to make some new marks. You could kind of let yours be. But now we want to go to 4 rectangles. So as I go to 4 rectangles, it's kind of nice because I can still see the marks there. I like that. Okay, so what's the width of each one going to be? The width is going to be 1. So I'm going to put marks at 1, 2, 3, and 4. Everybody good with that? So I've got 4 rectangles. So let's talk about it, okay? The first one, I draw the height at 1, and it goes up to there. Second one, I draw the height at 2, and it goes up to there. Third one, and finally the fourth one, up there. Great. That's a better estimation than the first one, right? You're still, like, mathematically, you're like, that's horrible. Like, there's a, like, really bad overestimation, right? I concur. So let's use our new formula. Instead of taking the width of each one, we just take the width times the sum of the heights. What is the width? 1 times, and now let's add up the heights. The height here is 1. Why? Because 1 squared is 1. What's the height here? 4. here, 9, here, 16. So we have 1 plus 4 plus 9 plus 16. Obviously, 1 times anything is itself. We get 30. So that's a lot better. We cut 10 units off, didn't we, in terms of our air. So we're much better. Let's go all the way to produce 8 rectangles. Just to help you get started, what is going to be the width of each rectangle? 1/2 of a unit. Try to work with those around you. See if you can determine the heights. You already know the width. You can use your calculator, but please come up with the expected amount. I'm going to go start your copies. Go. 1/2 times. What's the first number that you plugged in? 1/2. So you did 1/2 and you squared it. And you plugged in 1 and you squared it. You plugged in 1.5 or 1.5 and squared it. All the way down to 4 and squared it. And so you got 1/2 times. Does anybody remember what the number in the middle was? 51. And 1/2 of 51 was 25.5. So 25.5 is a correct estimation. Here's the cool thing. If we wanted to become more accurate, what would we do? We would increase the number of rectangles. So watch this. As you increase the number of rectangles, what's going to happen to the width? It's going to get smaller, right? And if it's getting smaller, what number is it approaching? It's approaching 0. What's going to happen to the sum of the numbers on the inside? They're going to increase. They're going to go towards... Oh, wow. We have a big question that we're asking in calculus, which is what is 0 times infinity? Now, you by nature might want to say, well, it's 0, when in fact, infinity is pretty big. Which one wins out? And in fact, people who look at this said, we don't need to look at 0 times infinity, but rather we can look at 1 over infinity, for isn't that 0? And we're going to multiply that by infinity. And so we're really looking at this. Have we done that before? We have. And so the word of calculus means the ability to calculate the infinitely large and the infinitely small. And you're seeing it on display right now. Flip it over. What? Yeah, it's still copying. I have some right here. Here, I'll give you a... Here. Yeah, thank you. Okay. What's that? Yeah, but I want that one. You don't get it. Sorry. Thank you. Okay, the next one. It says, use the following table. And it says, use the table to determine the approximate area bounded beneath the function from -2 to 6 using 2, 4, and 6 rectangles. Or 8 rectangles. Now, here's the difference. Are you given an equation this time? No. No worries. We can still do it. We are going to use this formula. The width times the sum of the heights. We start here. What's the width of the entire interval? 8. How many rectangles are we using? 2. So what's going to be the width of each rectangle? 4. 4 is the width. So I'm going to mark out your first rectangle. It starts at -2, and if it goes over 4 units, where does it go to? It goes over to 2. The next rectangle will go from 2 over to 6. So I have the width is 4. Now I got to multiply it by the sum of the heights. Our first rectangle, we're doing right-hand sums. So am I going to evaluate the height at -2 or at +2? At +2. What is the height of the function at 2? It is 7. Question. What's that?
She's saying she thinks the width is 5, but you don't have the first one.
Right.
Okay.
Okay. It's okay.
Let's get the height.
So the height is the function value. So f of 2 is 7. Yep, so then what is f of 6? It is 6. Question. So we have 8, or I'm sorry, we have a width of 8. So we go from negative 2 to 6, which is a width of 8. Agreed? And we're going to divide it into 2 parts. So you take 8 and divide it into 2. That means each one is 4. So this gives me a total of 4 times 13, which is 52. So that's that right hand for 2 rectangles. Work with your partner, see if you can come up with the 4 rectangle. Go. See where you got? There, the width is 8. There are 4 rectangles. So what is the width of each rectangle? 2. Any questions how I got 2? So then I go 2 units, I go 2 units, and I go 2 units, and I go 2 units. So am I evaluating the height at negative 2 or 0? 0, and I get 1. The next height is 7. The next height is 8. And the next height is 6. So therefore you have 2 times the sum of that. And I have 15 and 7 makes 22 times 2 is 44. Is that what you got? If I divide it into 8 rectangles, what's the width? 1. The width is 1. So the entire width is 8, and 8 rectangles will make a width of 1 for each one, right? Okay, now Ella is correct that there are 9 spots up here, but if you look, we have 1 unit, 2 units, 3, 4, 5, 6, 7, and 8. So, is the first height evaluated for 5 or for 10? 10. So then you just do 10 plus all the way over to 6. Agreed?
Why we get 5? We got 58. I got 58, but that doesn't make sense. I thought it was supposed to get small.
Okay, you're absolutely right. Good assumption. Now, the fact is if we have a very nicely behaving curve, it is going to become more accurate and go to a single number. But here's the problem. Look at this function. It's weird. It goes up to 10, then it drops to 1, and it goes all the way up to 16 and drops to 5. So as it has weird behavior, that's going to cause some issues from us from time to time.
Oh, so the lowest number would be the best guess?
Not necessarily. The best guess is actually where you have the most rectangles. So it is better than the previous one, but sometimes it can bounce back and forth. You're not going to see that real often, but this is one of those examples. Yeah.
You never count the first number in the rectangles?
If you're doing right hand. Now, if we talked about left hand,
Last number.
I didn't want to talk about left hand, but it gets brought up. If I want to do left hand, what's my first height? 5. What's my last height? 5. You don't use the 6 then. You see?
So you never use the first when you're doing left hand, and you never use the last.
You never use the first when you're doing right hand. You never use the last when you're doing left hand.
Okay. So it has so much sense.
So you know how all the numbers kind of like go back and forth?
Yeah.
Want to try another one?
You could. Our goal right now is not to become more accurate because we know that we'll be able to do this eventually where we're going to be able to do it precise. Like there will be no more estimation. But you need to understand, and that's what the AP test will do. They will give you the number of rectangles. And by this is designed exactly like the AP test. They will give you a function, okay? They will give you a set of table values. You don't know which one they're going to give you. And the third thing they'll give you, they'll just give you a picture. So let's look at that last one together. If they give you a picture, it says use the following, it should be graph, to determine an approximate area bounded beneath the function over the interval 0 to 8 using 2, 4, and 8 rectangles. What is my interval from what to what? So I'm going from 0, I'm going to draw a line there, and I'm going over to 8. Now this is really an approximation, so on your test there's no single answer that's correct. So there's a boundary that I would use. We're dividing it into 2 rectangles. So if it's 2 rectangles, I do my first split at 4. So when I draw the rectangle, I go over to 4 and I draw to the height. And then I go over to 8 and I draw the height there. Overestimation or under? Over, or definitely under, right? Like this is really under, this is just slightly over. So you can see geometrically, it makes sense. We could say it's going to be an underestimation. We know our formula, yes. That's okay. Yep. So 2 rectangles. So what's the width? So I have 4 times the sum of the heights. What is my first height approximately? 9. That will be fine. If you wrote 9.25, I don't care. If you wrote 8.75, I don't care. Plus, what is the approximate height for the next one? Okay, that's fine. That's fine. That's fine. So 9 plus 3 is 12 times 4 is 48. I do not want to do the 8 one, but quick do the 4 one with a partner of yours. Go. It's okay to not come up with the same answer. You should be within probably 3 units of each other. Okay, time out, folks. Okay, you are going to be, the bell's going to go here in a second. Pause. So here's what you can do. Number 1, when we get back on Monday, we are going to kind of start like 3 different problems from your homework to get you working on it a little bit. But if you would like to work through some of them, if you're like, oh yeah, I can for sure do this, definitely do it, because we'll spend about half the hour working and then the other half of the hour introducing right hand or introducing left hand and midpoint trapezoidal sum. Okay? So we will give you some time, but it wouldn't be bad to try the ones you can do. Okay? Good work. You guys are doing well. Proud of you. Way to go. Oh, I'm subbing 7th hour for Mr. Jeffrey. Anybody have 7th hour, Mr. Jeffrey?
Spencer does.
Spencer does. Awesome.
And Max.
All right. Later, Gator.